So functional programming is a paradigmatic shift to take us away from our code being a series of instructions for the computer that aren't really written for us to understand so clearly, and where every one of them can affect every other line, into a world where every single line is given a lovely human-readable name, and then we break down each of our lines into one of those individual functions, and then couple them back up, combine them back up into larger tasks. As we'll see in a moment, it produces code that is profoundly easier to debug, to interpret for others, and to add new features to. We just take the pre-saved little blocks, these little tiny functions, and join them back up. Now, we have to do some interesting feats to wrestle these individual mini tasks, these tiny functions, these units of code, back into larger tasks. We saw some of them today. Higher order functions let us combine and make individual code more specific by combining functions together. Composition or reduction of a series of functions allows us to pass data through, combine it with a function, pass it in the next function, return its output in the next function in a super readable manner. We then had to use closure to enable partial application, where our functions required multiple inputs, and yet if we're having them automatically run for us by just listing them out, they're expecting to only receive one input, and if we have multiple inputs, the whole system breaks down. But folk, there's even more. And the goal of today's talk was not to give you every one of those techniques. It was instead to give you some of the core techniques, understand them under the hood, so you're in the best possible position to go and tackle taking on all those further techniques out there to make your code capable of switching into this more functional style. There's libraries out there like Ramda, all of which have these elements, but go far beyond it as well. You hopefully now have the under the hood understanding of some of these core pieces on which you can now build those ever more sophisticated models. But wow, if you can do it, we get code that looks like a to-do list of tasks that I can pass to any fellow engineer, and they can say, here we are, taking in this player, we're taking in their name, we're then taking the first name, we're uppercasing it or propercasing it, we're adding a label prepended to it saying user, and then we're creating a template ready for our DOM, ready to render the DOM. Note, by the way, here, we might have had to partially apply one of these functions. What if our user template depends on some other piece of data? We might have had to pre-fill that other piece of data to make this create user template ready to run. Adding user label, we may want to add a more general label and pre-fill it with the specific label we want to add to that piece of data. All of that's going to use our partial application technique, all of which relies on closure. But if we can do it, folk, our code is now a set of independent, self-contained. This line, its only consequence is the next function. Get first name, we return out will. Only consequence, pass into proper case. Get will with uppercase W. We get it. These self-contained steps we can then wield, recombine up to solve any problem of our choice. We can become true composers of our code. It's been a pleasure sharing with you all some of the foundations of functional programming. You've gone under the hood of a small number today. Now take these core concepts and apply them in your own code, step by step, and then look to the many other concepts out there in functional programming. Use these foundational steps to take you through to understand those new concepts. Thank you so much, people. It's been a pleasure sharing with you this wonderful, ever more popular paradigm for writing our code at scale. Thank you.